Check, check, 1, 2, 2, 2. Looks good. What's up, everybody, and welcome to an episode of Daniel Fixes Crap in His Kitchen. I'm Daniel, and we're in my kitchen, and much to the dismay of my partner and my roommate, I'm fixing stuff in my kitchen. So that means I kind of take over the nice granite countertop, which is heat resistant, by the way. Granite, being a stone material, is actually, in a lot of ways, it's a great material to work on, as long as you protect it from scratches, as I'm doing. So I ended up buying a lot of Chauvet Colorado to Zoom Tour LED washes. And they were selling these stage lights as is, untested. And so I've had actually a lot of luck buying things as is, untested, and I have no problem buying things as is, untested, except when I bought them and as I was uncovering the problems that they had. There's that fine line between knowledge of a problem that item might have and just saying, oh, we didn't test it. Right, it sort of releases you from all liability. As is, it's a funky gray line, but I'm not going to buy from TBH Computing in Marietta again. So here we are, sitting at Daniel's kitchen counter, and we're going to look at these Colorado 2 Zoom LED washes. So this is one of 7 that I've worked on, and they all have similar problems. So the first thing we're going to do is we're going to plug it in, and we're going to test it and see what's wrong with it. So I got a cheapy little DMX controller over here. I'm sending it the master fader right here. And then this is supposed to be channel 2 is red, channel 3 is green, 4 is blue, 5 is white. So we are dead on any and all things green when we assign our fixture to DMX channel 1 in this configuration. So that's cool. All right. One thing I like to do before I work on anything is make sure that the instrument is totally discharged, meaning, you know, the capacitors aren't holding a charge, because that could hurt you if with some of these power supplies, they have big old capacitors. So I'm gonna unplug the power cord on the back of this while the LEDs are emitting, so that'll drain the capacitors in theory. There we go. And let's just take off this front lens and see what we see. 6-sided bit here. And we're just gonna, I don't have the nicest tools in the world. You know, hell, I don't even have my own workbench, right? That's why we're in my kitchen here. But the nice thing about working in your kitchen, of course, is you can listen to what you want. You can enjoy a little bit of Pinot Noir as you're dismantling these faulty Chauvets. One thing about the Chauvet brand, and I think I'm even saying it wrong, because, you know, I do this for fun. I'm a hobbyist at the end of the day. And I think it's pronounced Chauvet, but Chauvet just seems so much more French to me for some reason. So I'm going to go ahead and keep calling it Chauvet for the purpose of this video. This is the part that the plate that moves up and down to focus the actual LED light into a wide or a tight throw. So I got to use a different tool to take this off. Okay, now we have to remove this plate that is holding all these other little lenses in place. Now, one thing I like to do, so I'm faced with this, you know, this new screw. We haven't seen these screws yet. I like to try my bit, my little screwdriver drill bit, in the actual screw socket, in the actual head of the screw, and see which one kind of fits the most snug. I just kind of choose one, and I kind of stick it in there and just rub it back and forth. And if it doesn't move a lot, if it doesn't have a lot of give, then I feel like I've chosen a good one. You know, because the last thing you want to do is have to replace these screws that you're already taking this stuff apart for the purpose of troubleshooting some of these LEDs. Last thing you want to do is have to replace other parts that you may have damaged while taking this apart. You know, normally I like to listen to choral music while I'm working on this kind of stuff, but I'm afraid YouTube's gonna flag me for some sort of violation if I did that. So no music for you guys. You can't hear what I listen to. But today you can see that I'm enjoying a Pinot Noir. That's good. But no music. So here we are. Now we're at the LED PCB. You have to pardon the lighting. It's really direct, just coming through this window. Which actually, because I've turned 40 something, I wince because my vision's changing, and it actually kind of sucks. I need really direct light these days, you know, in a way that I didn't used to in the past. Okay, so this is the LED PCB. It's got this black coating, presumably to not only protect the traces that conduct the current across the board, but also this coating probably also makes it just look nicer, so that it's not reflecting a bunch of light around. You know, you're not seeing a green or a tan PCB board if you looked at the lens with the light off. But it also makes it really troublesome to work on, and so we're going to find out why in just a second. So first we got to remove all these little lights, so first we got to remove all these little lenses. And I'm using, this is one of those tools that comes free with like every like cell phone repair kit that you buy. It's just like a plastic little jimmy scraper something shimmy. I don't know what this is called, but I'm using that to get underneath all these little plastic individual lenses over each SMD LED. Because I don't want to break them, but I also don't want to scratch the the LED PCB. Now here's the thing. Here we come to why these things, or I don't know why, but it's the manifestation of how they're failing. So you can see all the SMD diodes just happily hanging out on the PCB board here, right? They're all this, and then these green ones for some reason come off. They just pop off. Presumably it's because of heat. So this one actually managed to melt the plastic lens that was over it and affix itself to the plastic lens. I mean, it's just one and the same. The part got so hot that it not only melted the plastic lens above it, but affixed itself and came off the board. So that's something going on, you know, that I'm sure they realized, we better change the design of these Colorado LED washes, and they sure did, because then I think after that the quad zoom came out. So that lens is garbage. We can't do anything with that one. And of course that would make the circuit of LEDs, green LEDs, open, right? It would just would cause an open circuit, because then without the SMD LED affixed to the PCB, you know, unsoldered, the circuit is broke, y'all. That circuit's broke. But that's only half the story, because what we're about to find out is that the way this is engineered and the way this is wired is that the green and the red and the blue, there's actually 2 circuits of them on each light, on each PCB. So we're gonna figure out what the other half of the story is. We found half of the green story, but we need to find the second half of the green story. All right. So that's cool. So I'm just gonna dump all those little jewels, all those little blessings into my little jewelry box here. So yeah, I'll throw these all in there too. Look, it's like an oil pan at a mechanic's workshop. It just keeps all your crap in one place. That's nice. So before we go any further, let's bump into the camera. That's awesome. So yeah, using my little DMX, controller here, I'm able to see that red LEDs are working. That's cool. The greens are all dead still. Next channel's blue. And one of the nice things about the PCB board is at least they identify what should be in what place, and they identify the polarity. You know, there's a plus and a minus. And so I see that all my B's are there. All my B's are working. On a lot of these, the whites go bad too. And instead of dying a death of an open circuit, the whites tend to die a death of a short circuit. And so, you know, if you use your multi-tester and put it on diode mode, as you would, a lot of the white LEDs would actually, if you went across from the plus and minus, they'd give you that short indicator. But on this one, all the whites are working, so that's exciting. All right, let's turn on our green channel on the DMX controller once more. And what we're gonna do is just use a pair of pliers. Now, if you remember the dead giveaway of the dead green LEDs was that this one SMD diode actually came off inside of its individual lens. It just melted onto there. So we knew that was going to be part of the circuit that died, overheated presumably. And so I see that these little solder pads, I'm looking at these little solder pads here, and they do look a little bit bad. You know, it's just kind of discolored and there's really no solder left. I wonder if they put enough solder to begin with, and that's one of the reasons why these fail. Anyway, so I'm going to use my little pliers. You wouldn't do this if this was like a high voltage circuit, like the backlights of a TV, for example. That'll kill you. But on these stage lights, you know, if you test across the terminals, driving this LED PCB board, you can see that it's low voltage, so I feel pretty confident about doing this. But I'm just going to short this using my tweezers, and sure enough, when I shorted the positive and the negative, where that missing green LED should be living, when I short them, the rest of that side of the circuit works. So we know that that's a dead one. We knew it from the beginning, but it's nice to confirm. I'm just going to mark it with a little, I have a metallic silver Sharpie. That shows well on the black. Now, there's still that second part of the green circuit that we're not sure about. And so it could be any one of these little dudes that's not lit up when so it's not going to be any of these guys. It's going to be all the G's. Oh, I think I found it. Isn't that funny? literally just by touching it, because again, it's doing the same symptom. It's doing the same thing that the one that actually fell off probably did, which is it's overheating, and then it's actually, the LED is coming apart from the circuit board. And so we are going to attack this little dude too. But first, we gotta remove it. Before we remove it, we gotta mark it so we remember which one. All right. Now, let's discharge our capacitors and the power supply of this light once more. I've turned, a bunch of lights, turned a bunch of the LEDs on that work, and then I simply remove the power con connector, and we don't need the DMX connector connected too. So these are discontinued, and I think it's for a really good reason. The reason being, you're gonna find out why here with me in just a second. But first, let's find I don't know what they call these, star bits, hex bits, something. I don't know. It fits in my drill, and it fits in the hole. So while I'm doing this, did we talk about selling things as is? When you sell things as is that a license? Does that give the seller a license to sell junk that they know is broken and know exactly is broken? I don't know. Here we are. So now we're fixing stuff, and we're in my kitchen. So this is the inside of these little dudes, and basically we got to undo every one of these little nylon straps, wire straps. And one of the awkward things about this particular LED wash by Chauvet is that the only way to get the LED PCB that we've been looking at off is to undo every one of these wiring harnesses and basically take apart this entire motorized mechanism here, because all the wiring harnesses tangle underneath. There's absolutely no connector on just directly on the PCB board, as there are in other Chauvet products or in other higher end products like ETC washes that I've also worked on some. Don't make me take the entire thing apart just to do this really routine thing, which is remove the LED PCB board, right? But that's what they make you do, and I think that's why this is now discontinued. Okay, so the only thing you'll have to remove from the power side of this enclosure, connecting to the LED driver and actual LED board side of this enclosure, the only thing you actually have to unhook is this little cable that connects to the thermistor on the LED PCB board, and that just tells, I guess, the power supply, hey, it's getting real hot, you should probably shut me off. So before I start taking these harnesses out, and it's not so troublesome if you forget, but it's always nice to retrace your steps. So this one's the only one that is that side, but there's two of these that are the same side. One's positive, all the positive leads for all the LEDs, and one's negative, and I'm just going to put a little negative side for the negative, and I'm going to do a little positive sign for the positive. That seems like a nice thing to do. So now we got to remove the motor assembly and the LED driver board, and I'm just gonna do the same thing where I double check my screwdriver bits to make sure they're appropriate for the type of screw head. Because as we've all discovered, one time or another, stripping the screw head, it's just annoying, and it's an unnecessary part that you didn't need to buy. Anyway, you can barely buy parts for these anymore. Because, oops, there we go. That one started to strip. Anyways, you can barely buy parts for these anyway because they're 10 years old. And so the only way to remove the LED PCB is to get all those, to free all those cables from under there. All right. So now we can go back to our, we can start pulling some of these cables on through, because we got to free up that thing. All right, so cool. So one thing I notice when I take these off is I don't think there's not an adequate amount of thermal grease, in my opinion, on the underside. Basically this giant heat sink that's an enclosure and the underside of the board. So we're gonna fix that later. But the good news is that we have freed the PCB board. Now I feel like I might as well just take a moment and congratulate myself on my progress with just a little more wine. First, I'm just gonna use a little rubbing alcohol. I'm just gonna clean up this board. I can't tell if this is like mold or dirt or corrosion or what's going on. There's this dark thing on the back of this. That's not just the thermal paste. It's not going to be easy, sweetie. It's always a mystery after it's been through a reseller and, oh, it's untested as is. No, because somebody sold it to you for pennies on the dollar, and then you sold it to a chump like me. The limitations of as-is transactions. Okay. So remember I made my 2 marks. And the 2 that I need to work on are at least on the same quadrant of the board, I guess you could say. So that's exciting. So here I am using my nice granite countertop that we just put in the kitchen. Again, to the discontentment of other people in this household. And we're just gonna get real hot next to it, okay? So what we gotta do is bring up the temperature of this board, which is backed with, you wanna make sure your PCB board is affixed, bonded permanently to a sheet of metal like this LED PCB is. I'm not sure how this would work if you just pointed a heat gun directly at a silicon board, for example. But this is backed with metal, which of course conducts heat away from it into the heat sink of the enclosure, and so it generally deals with heat pretty well. And so first we got to remove the faulty green one, and the other faulty green one was already removed for us by a fault of design or whatever, who knows. So we're just going to heat this up. Here I have a little meat thermometer, and I'm just gonna put that in there. I just put it in one of the screw holes. Why not? Really, first we're just doing this so that we can remove we gotta remove the LED that's still affixed to the board. And then we're gonna clean up those terminals, or those pads where the SMD actually sits. And so I know that a 3060, I think this is 3060 solder should start melting 300, it's 300 something degrees Fahrenheit. But you can, the Meath thermometer says we're about 300. Oh, there we go, yeah. That came off real easy. And who knows, who knows what kind of solder these were used on and what kind of factory these boards were manufactured. Maybe they were using a lower melting point solder, because my thing didn't even say that we were at 300 yet, and it was going through one of the through holes. So who knows? All right, so now I'm just going to clean up some of the old solder on the pad. I got my soldering iron here, and I got this wick, and I'm just gently removing the old. Out with the old and then in with the new. You'll see. We'll put some new stuff on there too. And not only am I removing solder, but it almost looks like I'm removing some black stuff. I don't know if that's an oxidation, or I don't know what's wrong with these pads that makes these green ones on these Colorado 2 Zoom Tour Chauvet fixtures just fly off, apparently, because this is the sixth one that I've worked on where the greens have just failed. They just fly off. If anyone knows, let me know in the comments. I'd be curious to learn. All right, so I removed most of the old gunk, and now it's just time for a little wine. I meant to show you so this is the LED, that flew off the board, and it just was melted onto the lens. I wanted to actually test that and see, well, did it just overheat? Is there a chance it still works? So I'm just gonna put my, oh my gosh, would you look at that? I'm doing a standard diode test. So the LED, there was nothing wrong with it. It still lights up green. Of course, it's massively burned and obviously overheated, so I'm not going to reuse it. Let's see. I will have to reuse its neighbor. Set that down in one of these little through holes and probe it as well. Yep. Yeah, she's. I know you can't see it on the video, but she's lighting up green, and she doesn't have any discoloration of her lens. Now, what we will have to do is the desoldering braid here, and get off any of the solder that we can from this component, because we want it to only pick up nice new solder that we're going to put on there. And then the second thing we have to do is to figure out the polarity of this particular SMD. And we have to figure out the polarity of this particular little dude. So I'm just comparing him to the other green LED SMDs that I have here. Oh shoot. Looks like my temperature thermistor contact also needs to be resoldered. Don't let me forget that. So on this particular one, I see that on the left hand side there's a couple markings, that and then I can line it up with the ones that are still soldered to the board and figure out its polarity pretty easily. All right, so I'll use that one, and I have one new one that I ordered left out of all these repairs I've done. All right. I'm sure there's a lot of different ways to do this. Some people say don't put any solder on the board, you know, before you heat gun SMDs, surface mount whatever's onto a circuit board. I'm gonna go ahead and say that we need some amount of solder on there, and that the reason why these green ones are flying off is just because there just wasn't enough, you know, to bond it to the board. And what can happen is if there's not enough contact with the pads here on the circuit board, that the component will actually make like an arc. If there's not enough surface area, then the tiny amount of surface area that is conducting current will get really super hot, and then that'll actually create like an arcing effect, which can melt solder, even if, you know, these are designed not to get that hot. I think that's why these little dudes were flying off the board, but that's just the theory. I have no idea. So let's, now that I've kind of prepped my pad with, just a little bit of, just the tiniest bit. I mean, it's just like the tiniest bit of solder. So I know there's a few ways to do this. I'm sure you'll tell me this is the wrong way to do it, but it's worked for me thus far. I like to place my SMD here. SM surface mount LED. I like to get it in place with the correct polarity like that, because I don't have the steadiest of hands. That kind of runs in the family. Where'd my other one go? What the hell? Oh no, I lost one of my components. So yeah, I like to set my SMD LEDs down before I get that heat gun going, because at first I was scared that the heat would, you know, melt them, and then I realized that they were actually sort of designed for pretty high heat, because yeah, they get really, really hot. That's why there's this gigantic, you know, why the entire enclosure of the light is built as a heat sink, because like that's how much heat that this thing has to get rid of. So I was like, okay, so I just decided I would set the SMD components down on my little solder pads that I've prepped. And since I've sort of shaky hands, that then I could position them and kind of mash them down once it got going. So let's get the heat gun going. Once this thing starts to heat the board up, you know, since the bottom side of the board is metal, like I said, the board gets really, really hot, so you really can't touch it. You can't use it to stabilize your hands. So what I like to do with these, at least, there's these little holes on each side of the each LED where the individual lenses will have their little mounting prongs, their little mounting points, and so I stick one end of my pliers in there, and then the other end of the pliers are just kind of squeeze over it. Now you can tell you've gotten hot enough when you see the solder literally turn like a shimmering sort of you know, glassy look to it, like a liquid look. And of course I can't show it to you on this, but you got to trust me that it's getting to that point. And it's at that point that I'm just gonna vaguely poke the top of this to help get it into place. and also to make sure that the solder, you know, for once, is actually touching the bottom of the component. So just the tiniest bit of pressure. Again, I was using one side of my tweezers as a as kind of a grounding point in that little hole, and then just, you know, just vaguely pressing down on the top of each little diode. And now we're gonna let it cool. Now you have to be very careful, as I quickly learned. When you heat up this board, you heat up all of the LEDs. So now, you know, during that time when the solder was molten under the ones I wanted to fix, the solder was molten under all of the LEDs. And so if you bump any of those, ooh, they'll get out of place. In some ways, you know, for a board that's been malfunctioning, I feel like it's probably good. It's actually kind of like resoldering those SMDs to the board. Maybe it's a good thing. But you do have to be careful not to bump anything. And I'm going to use this opportunity to re-solder the thermistor. I'm assuming it's a thermistor. I'm not sure, because I'm not an electrical engineer. I'm a hobbyist. I'm not sure it's the thermistor, but a thermistor would be a variable resistor that would vary in resistance based on temperature, aka, you know, therm. And so then that would radio back to the power supply. Hey, you better interrupt that power, ramp it down, or whatever it's supposed to do. Tell the user that your LED PCB is overheating. All right, so let's just resolder that little thermistor wire. I wonder how that got. Now we've put so we've placed our diodes with the heat gun. We do want to do a quick check with the in the diode mode of the multimeter, and just probe and make sure that they do light up. That means that they're getting power from the board. It's that we've actually, you know, completed the circuit with them. And that they're, you know, the pads are conducting the electricity as they should. Because if they ain't, we got to heat it up all over again, and that's a pain in the butt too. Actually, everything about this project's a huge pain in the butt. But you know, what are you gonna do? You gotta save your lights. You gotta save some money. All that jazz. So what we're gonna do is we're gonna plug it into the board. Now we're going to double check and make sure our, you know, power is in fact off. Wouldn't that be nice to check? And we made our little markings for plus and minus, so we know that this one is the negative, and this one's going to go to the positive. Now what I found when I was doing the others is that you don't actually have to connect to the thermistor thing. The light will still actually work without it, so that's cool for our testing purposes, but it's also disturbing in a way. All right, now we can power her up. Of course, making sure that, you know, there's no metal is touching the outer enclosure and stuff. You know, we don't want to short circuit or cause any big dramas. So, and then we want to plug in our DMX 3-pin DMX cable, aka 3-pin XLR cable. And you can argue me this all day long. A 3-pin DMX cable is the same thing as a microphone XLR cable. It all depends on how you terminate it at the last instrument in the universe. Okay, it's all the same. A shielded 2-conductor cable at the end of the day. Thank you. Okay, so we're gonna turn up our master, and we got our, it looks like we have our reds. All our red SMDs are working. That's good. And so, you know, because of the heat gun, and like I said, it loosens up all those LEDs from the PCB board. These could all be screwed up. Oh, what? I see all the greens. That's a good sign. Our blues. I see all the blue. And our precarious whites. Okay. This is great news. So we did good. All right. We do want to test this at full blast. And so what I like to do, and you're going to laugh at me for this, I like to take my meat thermometer and connect it so that the long side of it goes across the back of this, you know, metal board, metal LED board. And, you know, so it's getting an accurate temperature reading at the end of the day, because it's making full contact. And I like to cook it up to about 130 degrees. It kind of stops. It just starts kind of hanging out at that point. But with everything on full blast. So we'll just let that cook up. And we want to be present in the room in case there's, you know, anything smokes or what can happen during this part of the testing is that if like I said, one of the surface mount LEDs has just, you know, if it's just conducting just on a tiny surface area of the underside of it and not the entire surface area, then it could potentially start arcing. And the arcing can create quite a bit of heat, and then that'll actually melt the solder, and the LED will just go pop. It'll just pop off the board during this testing. So let's let that cook for a while and see how we're doing for 10-15 minutes. And it seems like it gets up to 100 degrees really quickly, and then it sort of just hangs out, you know, between 100 and 130. So right now we're at 127, and, you know, nothing's exploded, nothing's fallen off. I do want to just kill this really quick. Kill the, and we're just going to probe around on those SMD LEDs that we previously removed and put back on. And make sure, we're just going to give them a good little jab with this little plastic thing. And in hopes that we could knock them off if the solder joints weren't done correctly. So it's just this fine line, just the tiniest bit of solder after you use the solder wick on there. On those pads after you clean them up for the bad LEDs. And yeah, so this was fun. This is what you have to do. The whole process for each stage light with these Colorado 2, Chauvet Colorado 2 Zoom tours, is the whole process is like 2 hours each. So that's why I think people end up liquidating these and not trying to repair them, because it's so annoying the way they engineered these wires, you know, these cables to be underneath everything, and it's just really tedious to replace those SMDs. But it sure is rewarding when you do it right. So thanks for coming to my kitchen. I've finished off the better part of a bottle of Pinot Noir with you today, and this was just so much fun. So fix things, It always makes you feel good. And thanks. I'm Daniel.